So, welcome to lesson one in math, Scott Brown Prep Introduction to Geometry. So, this lesson will all be about SAT math and geometry in the SAT. So, let's start with some basics. So, the SAT uses geometric notation to describe lines, rays, points, angles, etc. Geometric notation is sometimes not covered in high school geometry, so you may not have seen this before. Don't worry, geometric notation is simple and easy to learn. So some examples of geometric notation is that this line over some two variables like a, b means that the line goes through points a, b, and continues on to infinity. The little arrows on the ends of the line mean an infinite extension into space. So it just goes on in one direction forever and never stops. The dotted line over AB means that there is a line segment with endpoints A and B. Since there are no arrowheads, this given segment does not go on to infinity. So since there are no little arrows at the very end of each of the lines, it means that it doesn't go on to infinity and it stops at a certain point. One line over AB means that there is a ray with an endpoint A that goes through B and stretches on to infinity. So it's similar to a line, except it's a combination of a line and a line segment, in that the ray starts at one point and goes on to infinity in a different direction. Similarly, a ray over BA means that there is a ray with endpoint B that goes through A and stretches on to infinity. So the first letter of each combination means that there is a line segment or a point, and that's where the point starts. Measure of angle ABC means the measure of the angle with point B as the vertex. So the middle letter in the three-letter word is always the vertex. And with point A on one leg and point C on the other. So B is always the vertex, with A being on one leg and C on the other leg of a triangle, or any polygon. So the triangle ABC means a triangle with vertices A, B, and C. Now, this one's pretty self-explanatory. In itself, we have a triangle shape followed by three letters. These three letters are three vertices of the triangle. The middle one always being the vertex of the triangle, or the middle one always being the vertex of the angle measurement, but they can go in any order. So quadrilateral with this four-sided figure means quadrilateral ABCD means the quadrilateral with vertices A, B, C, and D. So AB, so basically what this means is that AB and CD are all points on quadrilateral. So it's very similar to the one above, with triangle ABC being a triangle with vertices ABC. The only difference is that there's an extra point added to the quadrilateral, which is vertex D. AEB with an upside down T, BC, means that the line segments AB and BC are perpendicular to one another. So what perpendicular means is that it forms right angles, two or four right angles, but normally four, and that they're always 90 degrees. Points and lines. So a unique line can be created by connecting any 2 points. Between any 2 points on a line, there is a midpoint that is halfway between the 2 points. Any 3 or more points may or may not fall on the same line. If they do, then we say that the points are collinear. So this one is also pretty self-explanatory. A midpoint is basically the middle of 2 points, which is why it's a halfway, so it's half of the distance. And any 3 or more points may or may not fall on the same line. If they do fall on the same line, then they are collinear. That's also pretty self-explanatory. Collinear meaning being on the same line, and coplanar being on the same plane. Angles in the plane. To measure how wide or big an angle is, we use a unit called degrees. So these three examples are the most important examples in mathematics: 45-degree angle, 90-degree angle, and 180-degree angle. So 180-degree angle is just a straight line. There's nothing special about it, it's just a straight line. And a 90-degree angle looks sort of like half a square, you see here. So we call it a right angle. The supplementary angles are two angles that add up to 180 degrees. Complementary angles are two angles that add up to 90 degrees. So one tactic that I have for this is that supplementary angles, since they add up to 180, there's a little trick. So we can say that we can put a 1, slash it, and make this u a 0, and it looks like 180. And similarly, we can do the same thing for complementary. Ooh. complementary angles, in which since they add up to 90 degrees, we can say that this is just 90 degrees. Okay. So when two lines intersect, angles opposite of each other are equal in measure. So these are called vertical angles. When two angles are opposite of each other are equal in measure. So as you can see here, angle A is equivalent to angle B, always when two lines intersect. Unless a third line intersects it, in which case it will be a little different story. Alright, triangles. So in triangles, the sum of the three angles is always 180 degrees. That's pretty self-explanatory in itself. It's very basic and it's fundamentary for geometry in that the triangle is 180 degrees. In any triangle, the longest side is always opposite of the biggest angle, and the shortest side is always short of the smallest angle. So if we create a triangle, we say we have 7, 8, and 9. So the angle opposite of 9 has to be the biggest angle. So this is the biggest angle, and this is the smallest angle right here. That's basically what the theorem says, that the side opposite the biggest angle is the biggest side as well. Same thing with the smallest side and smallest angle. In the equilateral triangle, all the sides are the same length and all the angles are 60 degrees, which basically says that in the equilateral triangle, all the angles are 60 degrees, which means that all the sides are the same. The sides can be different, but they have to be the same all around, all three around. And the angles must be 60 degrees. Okay. Oops. So in an isosceles triangle, two of the three sides are the same length as each other, and two of the angles are the same measure as each other. So if we look at an isosceles triangle, for example, bottom two are always the same, which means that these two side lengths are the same. So it's also very fundamental for geometry, learning these types of triangles. Okay. Now a right triangle is a triangle with one 90-degree angle in its angle. And that's one of the three angles. So one way to know if an angle is a right angle is if there's a square, like here, a square on the corner. So these three triangles are these next two triangles are going to be very important, as well as the theorems. So if the angle measurements are 45 degrees, 45 degrees, and 90 degrees, the side lengths have a ratio of 1 square root of 2. So if you look at this triangle, for example, we have 90, 45, and 45 degrees. So this is the triangle that is formed. It can become in any variation as well. For example, if you multiply by the same factor, it can be the same. So we have 2, 2, and then 2 root 2. Next triangle is a 30, 60, 90 triangle. So this is also very important to know for geometry, because it's very easy for also on SAT. It's very important to memorize. There are a lot of questions about geometry that have some question pertaining to this. So the same thing as a 45, 45, 90 triangle, when we have a factor. If you multiply by the same factor, all the side lengths would be the same way. Okay. So now the Pythagorean theorem. If you take the lengths of the two shorter sides of legs and square them, and add those two squares together, the resulting amount is a square of the length of the longest side, or the hypotenuse. So in a practice triangle, so example of this theorem, it's like we have a 3, 4, 5 triangle. So we have a squared, we'll say it's 3, so it's 9, because that's 3 squared, plus 4 squared, which is 16. That equals to 25. Okay. So if we take the square root of 25, we get the longest side, which is 5. Okay, so moving on to triangles, more triangles. So Pythagorean triple is a set of 3 numbers that can be lengths of the sides of a right triangle. If you know 2 of these lengths, you'll be able to know the third trick using this trick. Memorizing these tricks can make solving right triangle problems faster. So the following 4 bullet points is a list of right triangles. They're all Pythagorean triples, which means that they're pretty much key are always like this no matter what. There are probably a lot more, but these are the four most important ones you have to know. The 3, 4, 5 triangle, as the example we did before. 1, 1 square root 2, which is the 45, 45, 90 triangle. 1 square root 3 and 2, the 30, 60, 90 triangle, and 5, 12, 13, which is another right triangle that you should know. So if we look at a 5, 13 triangle, for instance, 5, 12, and try to solve for the hypotenuse, we'll do a squared, 12 squared, plus 25 squared, which is 25, equals 169. And then square root of 169 is 13. When we multiply each number in a Pythagorean triple by the same number, we get another Pythagorean triple. For example, since we know that 3, 4, 5 is a Pythagorean triple, then we also know that 6, 8, 10 is a Pythagorean triple, because 6, 8, 10 is what we get when we multiply 3, 4, and 5 by 2. So similar to above, if you multiply by the same factor in any given triangle, the side lengths will always be the same. So let's say for Pythagorean triple, so let's take the 5, 13, 12, 5, 12, 13 triangle for example. So if we multiply each side by 10, or by multiply both sides by 2, we get 10, 24, and then 26 side. So it's basically the same. So if you use the Pythagorean theorem, you get that both of these are both Pythagorean triples. So two triangles are similar triangles if they all have the same angle measurements for each corresponding angle. The formula for the area of a right triangle is base times height divided by 2 and is provided at the front of every SAT math section. So doing SAT math section, it's very important to memorize all of the key formulas and key points and triangles, simply because it saves you a lot of time from flipping through the paper. So look at the area of a right triangle, base times height divided by 2. So let's create a triangle here. It's our right triangle. We say the base is 4 and the height is 12. Now trying to find the area. So we know that the area is base times height divided by 2. So the base is 4, the height is 12, we divide it by 2, and we get 24. So this is the same formula for all triangles. Also, the triangle is always the base times the height divided by 2. Okay. On every triangle, the length of each side must be less than the sum of the lengths of the other sides. If this were not the case, the triangle will not be able to close. So let's take another triangle. Let's take the 5, 12, 13 triangle. Once again, 5, 12, and 13. So in this example, we have 3 different possibilities for addition. 5 plus 12, 5 plus 13, and 13 plus 12. So in every case, the sum is always greater than the length of the third side, in which we have the third side here being 13, 12, 5. But if this were not the case, we look in another triangle. We'll use a 5, 12, 38 triangle. We get 5 plus 38, 5 plus 12, and 38 plus 12. So this one is equal to 43, 17, and 450. As you can see in the third line, this is so 17 is less than 38, third side 38. So this cannot be a triangle. Okay, now move on to quadrilaterals. So in quadrilaterals, a parallelogram is a four-sided figure, which both pairs of opposite sides are parallel to each other. So it's like a rectangle, and square, in which opposite sides are parallel, like in the diagram below. So in a parallelogram, opposite angles are equal to each other, and the measures of all the angles added up equals 360 degrees, which makes sense because in a quadrilateral, for example, like a rectangle, if you cut it in half, each triangle, each section creates a triangle. So if you look at the formula, you can derive the next formula for parallelogram or rectangle. So rectangles are special parallelograms that have 90-degree angles. In a rectangle, if you know the length of the sides, then you can figure out the length from one corner to the opposite corner using Pythagorean theorem. So since we discussed that if you cut a rectangle by diagonal, you have the width, the length, the diagonal. So we can use the Pythagorean theorem here as well. So instead of using A, B, and C, we use WLD. So W squared equals plus L squared equals T squared. Still the formula. And geometry calculations. So perimeters and angles. The perimeter is a sum of the length of its sides, and the perimeter is called the circumference. To find the perimeter, add up the side length of all the sides. That's pretty self-explanatory. The perimeter is the outer region, so you add up all the sides. And the formula for the circumference of a circle is 2 pi r or pi d. R stands for the radius and d stands for diameter. So let's look at an example of the perimeter of a circle or circumference with the radius 4. So we know that the circumference formula is 2 times pi times r, which is the radius. Since we know that the radius is 4, we can just plug it in and say that 2 pi times 4 equals 8 pi. So the sum of the angle measurements of any polygon can be determined with a single formula, s minus 2 times 180. Let's look at an example for the formula s minus 2 times 180. Let's look at a pentagon first, hexagon. So the side length is 6, so we plug 6 in, we get 6 minus 2 times 180. And as a result from this, we get 4 times 180, which is 700. So that we can tell the angle measure of the side length, the angle measurement in the hexagon is 720 degrees. And notice that we use degrees here as well in the future. So let's start to solving complicated geometry problems. So we can split the shape into shapes we're familiar with. So once again, let's look at the hexagon. So we can divide this up into into different triangles as well. And from there, we can find the side lengths. This is a bad example, but we can find the area of one triangle and multiply it by 6. Okay. So, and then our last one is the area. So the area of a two-dimensional figure is the amount of space that the figure covers. So all the area formulas you need to know will be provided to you in the front of the book and in front of every math section. But it's also, to save time, it's better to memorize the formulas. So the area of a rectangle is the length times the width. So if we look at the area of a rectangle, for example, let's look at 4 times 12. So here's the width and here's the length. And we know that the formula is width times length. So we do 4 times 12 equals 48. Now, formula for area of a circle is pi times r again. So if we look at another circle, we use the same one with radius 4. Have pi times the radius again. So we have 4. So pi times 4 times 4, which is 16 pi. And 16 pi becomes your answer. Okay, that wraps up today's lesson for geometry of SAT Math. Remember to memorize all the formulas as well as the little tips and tricks. And talk to you guys next week.